Okay, today we're going to talk about acid ionization. It's when we have an acid, it reacts with water to form its conjugate base and a hydronium ion. For this question, we want to find the pH of a 0.021 molar aqueous solution of boric acid. So, there's our reaction. We have the boric acid, and it's reacting with water, and it forms an equilibrium with its conjugate base and the hydronium ion. To calculate the pH of this, we need to find the molar concentration of the hydronium ion. This part of the acid ionization section, we will learn about the setup to find the hydronium ion concentration. In part 2, we will talk about finding the pH. So, we know that the acid ionization constant, Ka, is equal to the products of the molar concentration of the products divided by the molar concentration of the reactants. Here are products, and on the left side of the equation are reactants. So if we write this out, we have the conjugate base multiplied by the hydronium ion, all divided by the molar concentrations of boric acid times water. For equilibrium equations, finding the acid ionization constant, we know that water is equal to 1. So we don't need to worry about that in calculating the hydronium ion concentration. So to find this value, we need to find all of these molar concentrations in the equilibrium value. We only know its initial concentration of boric acid. That was given to be 0.021. And we don't know what hydronium ion or its conjugate base is. So in order to find that, we go back to the equation and we do what's called an ice table. Your initial concentration, the change, and reaction, ice. So we're given the initial concentration of boric acid. Now, when it goes through the reaction, there will be less boric acid in the solution and more products. It will equal out. So that 0.021 molar concentration will change by a variable of x, we'll call. So at equilibrium, its value will be 0.021 minus x. For water, we don't have to worry about. Now the conjugate base, we know its initial concentration in the solution is 0. There is no conjugate base before the boric acid reacts with the water. It has to react first. So the change we will designate to be x. And at equilibrium, its value is x. Now the same thing happens with the hydronium ion concentration. Its initial value is 0. When the acid dissociates, it's going to have some hydronium ion in the solution. And we'll give that as a value of x. Now, as we go back to the acid ionization equation, we can substitute in the values. We know that our products are, and we know what our reactant is. So all we have to do is sub it in. Now we have the setup of the acid ionization, and we can solve for x. This will be discussed in the next section.